Hi, good afternoon. Today is Friday the 18th. So today we're going to be covering two sections, 3.11 and 3.7, which is density and temperature and the temperature scale. So today's lesson is going to be really, really quick. So please, if you have to, pause to catch up or whatever it is that you need to do. Okay. So first off, the PDF for 3.7 includes 3.16 significant figures. Do not complete. This is not a section that we're going to cover. It's actually a section that we're going to skip. So I just wanted to tell you that before we get started. Okay. So the first topic for the day is density. Density is a really important um, property of substances. We use density most of the time to determine if a substance will sink and float. It's also used as a conversion between mass and volume. Okay, so it's really, really important. So let's get to studying density. So, first off, let's examine the picture that we have. The picture that they give us is these logs by, of course, from a logging company, and they're being floated down a river to, whatever their destination is. Obviously, it was up a mountain or, in the country, and they're obviously going to they're transporting it to probably the logging company where they will get nice and cleaned for building, for building whatever it is that we need in society, for new homes, there's different purposes. Okay. Now, why are they floating? Because the density of the wood is less than the density of the water. Okay. Water is considered to be extremely heavy as far as density is concerned. It says here that water has a density of 1 gram per milliliter. So that's pretty much pretty heavy, okay? Especially if you've been carrying around that 5 gallon bottle when you go to the water mill for mom and dad. You can tell how heavy 5 gallons is when you're transferring it after it's been full. What is density? Well, density is a ratio that from mass that relates the mass of an object to its volume. And this is your formula. Density is equal to mass over volume. Now, let's talk about the units associated with each variable, okay? So first off, let's talk about density. So density will be equal to mass over volume. And why am I writing in cursive? I don't know. All right. So here we have mass divided by volume, and that will equal density. Now, the units for mass, you always have to remember that the base unit for mass is grams, okay? Now, when it comes to volume, you can have two different units. It could be the milliliter or cubic centimeters, okay? Cubic centimeters, sorry. Density has also two sets of units. If you're using milliliters, you're going to have your unit for density to be grams per milliliter. And if your volume was in centimeters cubed, well, you're going to have units of grams per cubic centimeter. Okay. Don't worry about the volume. Both of those units equal each other, so they are interchangeable. Okay. So just because your density is in milliliters and your volume is in cubic centimeters, it's the same thing. Okay. I would either change both of them to milliliters or both of them to centimeters cubed. It's up to you. Okay. Make sure that you have this handy, especially when we're doing our practice problems. Okay. So, a little bit about density is the fact that it's known as an intensive property. Here, density is something that we have not covered. Intensive properties is something that we have not covered yet. but will be covered later in the semester. But what an intensive property is it is not mass dependent, okay? Density is something that doesn't change depending on the volume or how much you have, okay? It's not dependent on measurements, okay? It's something that is a feature of all samples of that material, okay? If I have a cup of water, the density is still 1 gram per milliliter. If I have a river, it's still 1 gram per milliliter. If I have an ocean, it's still 1 gram per milliliter. Okay, this is what we mean by it does not depend on the amount present. Some information you need to know is that most solids and liquids have densities that are conveniently expressed in grams per cubic centimeter or in grams per milliliter. Gases are considerably much less dense than liquids and solids. So their density units will be a little bit different. It'll be grams per liter. And here you have an example or some examples of substances with different densities, okay? If you look here, ethanol, ice, and corn oil, all of these three will float. Now, the question is why? Well, if you look here at water, water is 1 gram per milliliter, okay? So anything that has a density that's less than 1 will float. So ethanol, ice, and corn oil will definitely float if you're ever mixing it with water. All right. On the other hand, if your density is larger or bigger than 1, then you will have a tendency to float if that substance is put into water. Okay. Here are some examples of some densities of gases. You can tell that most of them are really, really small, except when you take into account radon. Radon is pretty heavy compared to all these other gases. Okay. Since most materials expand as temperature increases, expand means the volume's getting bigger. The density of a substance is temperature dependent and usually will decrease as the temperature increases. So if temperature goes up, volume expands just a little bit, and that will decrease our density just a tad bit, okay? Just keep that in mind. So here we have a sample problem. We have an 18.2 gram sample of zinc metal that has a volume of 2.55 cubic centimeters, and they want us to calculate the density. So let's go to our Jamboard so that we can do some practice, okay? And I already have it set up. So here's our sample question. They went ahead and they already put the known information where it belongs. But if we didn't have this known information, how would I know that it's volume? How would I know that it's mass? Okay, that's a really good question. All right. So what I would look at is I would look at the unit behind our numbers. Okay. So if you'll notice for 18.2, we have grams. So if you recall, when it comes to mass, the unit for mass is always grams. Okay. Now for volume, remember, volume had 2 units. It had milliliters and cubic centimeters. Okay. So that's just something to keep in mind. All right. So in case you are confused, always look at the unit and it will help you determine whether it's mass, whether it's volume, or whether it's density. Okay. I hope I got that clear to you. All right, now we're going to be using a strategy known as the pyramid. Some people call it the triangle. My students in the past have called it the Dorito. Basically, this is what it looks like. It's basically a triangle, and it's got a T in the middle. Okay. Now, what this line, this horizontal line, what it represents is, you got to remember, mathematically, it's division. Okay. And this line that goes vertical up and down, that line will represent the multiplication. Okay. So if we input our information, we already know that mass is 18.2. We know that volume is 2.55. So let's plug it in. So first thing we need to remember is that density will go here on the bottom. Mass will go on top. Volume will go on the bottom right. Okay. So we set up a secondary pyramid. But this pyramid we're going to use to actually input our numbers so that we can actually see what we need to do in order to solve. All right. So let's go ahead. Mass is 18.2. So M will be represented by 18.2 grams. And our volume will be represented by 2.55. And that is cubic centimeters. Sorry. Now, remember, we have numbers on top and on bottom of this horizontal line. So what are we going to do? We're going to be dividing, okay? Once we divide these two numbers, we're able to calculate density. So this is where we're going to take out our calculator and, we're going to zero it out first. We're going to punch in 18.2 and we're just going to hit divide and we're going to put in that 2.55, okay? The top number is the number that you will use to punch in first, okay? Never punch in the bigger number. It's always the top number, okay? I don't want you to get confused. So our answer in this case for density would be 7.13 grams per, and I was already going to put milliliters, cubic centimeters. Okay, and I always ask you guys to put it in a box or circle it. Now let's talk about credit. In order for you to get full credit for this problem, you have to show me your pyramid, your setup, and then you need to show me your final answer, and you have to make sure that you include the unit of that final answer, okay? And we already discussed units. I gave that to you when I gave you that formula, okay? Remember, mass is in grams, volume is in milliliters or centimeters, and density will either have grams and milliliters or grams and cubic centimeters. It all depends, okay? All right. Next one. Well, let's verify. As you can see, our answer came out the same. That's great. Awesome. And what they did is they divided just like we did. So we have a secondary problem that they want us to try. I again have already put it in our Jamboard. So all we're going to do is we're going to fill in the information that is provided. Okay. Now bear with me. It's I don't have a lot of room, so I'm going to try my best. All right. So here it says, what is the mass of 2.49 cubic centimeters of aluminum? So first thing, look at the number. What is the unit behind this number? It is cubic centimeters, okay? Cubic centimeters, if you'll recall, is volume. All right, so we're going to go ahead and put 2.49 centimeters cubed. And the question is, it even says it, what is the mass? So we are searching for M for mass, okay? That's our unknown. Now, we need density. Now, here, they don't provide it to you. So they'll probably give you a table like they did in the reading. And remember the table that we looked at earlier? This is the same table. As you can see, aluminum is listed right here. It has a 2.70 gram per milliliter density. So we're going to go back and we're going to use that density for aluminum. Okay. So we're going to put 2.70 grams per milliliter. And does it matter if our volume is different units? No. But do we like to keep the same units? Yes. So we're just going to cross this out and we're just going to put ml just in case, okay? That way we don't get confused. All right. So then we're going to go to our triangle. Okay, we know mass always has the top part of our triangle or our pyramid. Now, if you'll recall, density is always on the left, volume is always on the right. So I'm going to input that information. Density, 2.7 grams per milliliter. Volume, 2.49 milliliters, okay? Now, remember, what did we say when we have numbers on opposite sides of this vertical line? If you'll recall, that vertical line represents multiplication. So if we get our calculator again, and the normal regular calculator will do, you don't need a scientific one for this. We're going to punch in 2.7 times 2.49, and we're going to get 6.723. Okay, so I'm going to go here on top, and I'm going to put mass equals, I already put the wrong number, 6.72 grams, right? Because we know it's mass. Okay, now let's go to the second question. The second question, and let me just move this up so it's not in our way. The second question is, what is the volume of 50 grams of aluminum? Okay, I'm not even going to look at the question. The only thing I'm focused right now on is the number and the unit that's associated. Okay, so I'm looking at 50, I'm analyzing, I'm saying, okay, what is G? What is G? G is grams. Okay, grams is, and I go to my notes, okay, I remember, oh, it's mass. So then I go and I start inputting my mass as 2.49. I'm sorry, that's wrong. I was using the other number. It's actually 50. Sorry, I got excited. So 50 grams is our mass. The question even says, what is the volume? So V is what we're looking for. And density is for aluminum, which we already know from the previous question. 2.7 grams per milliliter. We're going to create our triangle. Uh-oh, I ran out of space. Okay. All right, I can put it here. We're going to create our triangle. We're going to put the T in the middle. We know mass is always on top, so we're going to put our 50 grams on top. And then we're going to put our density in the same place that we put it earlier, on the left. And we're going to put V for volume. Now, remember what happens when we're working with numbers on opposite sides of this horizontal line. You recall? It is, we're going to, if you remember, we're going to divide. So we're going to take our top number, not the big number. We're not thinking that way. We're saying top divided by bottom. So we go to our calculator, we zero it out, we start punching in 50 divided by 2.7, and we get this number 18.52 if we round it correctly, right? So then we're going to go to the top, we're going to put volume V is equal to 18.52, and our volume is the milliliter. Okay? All right. If we need to do it again, obviously just rewind. All right. So let's go back to our presentation. We look at the answers exactly with what we came up with. So awesome. We did great. Here you have some practice videos. If you want to do some extra practice, there's some videos there. Okay. And we are going straight into the summary. So density is a ratio of the mass of an object to its volume. Gases are less dense than either solids or liquid. Both liquid and solid materials can have a variety of densities. For liquids and gases, the temperature will affect the density to some extent. All right, so here you have 6 questions. Question 6 is based off the table above. So make sure that you use that table for question 6. Okay. I don't want anybody saying, Miss, I couldn't do 6. Okay. No. Just look at the table above and then see what density, what substance is close to the density that's given in the question. All right. So now we're going to move on to temperature. Okay. And temperature is going to be really, really quick as well. All right. So 3.7 temperature and the temperature scale. Here they start by talking about an ice cube in your hand and why it feels so cold. Okay. Now, when you have something in your hand, you have to remember that us as humans, we have a certain temperature that is used to regulate our body. It's about 90 something percent, 96.1, 96 point something. So you'll recall if you have an ice cube in your hand, that's the temperature of that ice is really, really low in comparison to the heat in your body. Okay, so that's how come you'll feel it cold. Also, that ice and us as people have kinetic energy. This is the energy due to motion. Now, you have to remember we can move a lot, so we can get really, really hot, especially when we're working out. You'll see some people turn red because their body is producing a lot of heat due to the motion. Okay. So here you have the definition of temperature. Temperature is a measure of the average kinetic energy of particles in matter. Okay. In everyday use, temperature will indicate how hot or cold an object is. You got to remember that temperature is an important parameter in chemistry. Why? When a substance changes from a solid to a liquid, it's probably because the temperature of the material has increased. Also, temperature and heat can make chemical reactions process faster. Okay, and this is because we're adding more heat to the reaction. Here you have some examples of you have a barbecue going. Obviously, you need to burn some wood. That is an example of high kinetic energy. Now, if you're on the opposite end and you're somewhere where it's really, really cold and snowing, some of you migrants, you guys travel to these really cold states that have a lot of snow. Well, if you are measuring the kinetic energy of people, of substances, of places up there, you'll notice that the kinetic energy is a lot lower. Now, there's a couple of scales that you need to be familiar with. The first one that comes up is known as the Fahrenheit scale. It's based off of, or it's named after German scientist Daniel Gabriel Fahrenheit, who used mercury in a tube to create the first thermometer, okay, or a version of the thermometer. Maybe not exactly the first one, but he did create a version of it, okay? And the most important thing that you have to remember, there is a problem. The main problem with this scale is the arbitrary definitions of temperature. So if you're thinking of the freezing point and boiling point of water based on the Fahrenheit scale, water will freeze at 32 degrees Fahrenheit and it will boil at 212 degrees Fahrenheit. Okay, we don't usually use the Fahrenheit scale in science. And here you have a picture of Mr. Fahrenheit. You can see he has a version of a thermometer, and you can see that he's probably heating something up in this tube-like structure that he has, right? Because that looks like smoke, like that's being let out. The next scale that you need to talk about, or that we're going to talk about, that you need to know, is the Celsius scale of the metric system, named after Swedish astronomer Anders Celsius, and he was around in the 1700s. The Celsius scale sets the freezing point and boiling point of water at 0 degrees Celsius and 100 degrees Celsius, respectively. The distance between 2 points is divided into 100 equal intervals, each of which is 1 degree. Another term used for the Celsius scale is known as centigrade because there are 100 degrees between freezing and boiling points of water on this scale. Okay, but most of the time, we use Celsius. And here you have a picture of Mr. Anders Celsius, and you can see he has a very nice set of hair. Okay, look at that. Very, very fancy. All right, and the final scale, this is the one that we use in science a lot, is the Kelvin scale. Okay, it's named after Scottish physicist and mathematician, Lord Kelvin, and he was around in the mid 1800s all the way to the early 1900s. So he lived a very long life. I'm so sorry. Now, the thing about this scale is that it's based on the molecular motion. So a temperature that you need to be familiar with is known as 0 Kelvin. What 0 Kelvin is known as is known as absolute zero. This is the temperature at which point all molecular motion, all atoms, all particles, all particles will cease to move. They will finally stand still. Okay. Particles, even in this solid container, all the particles that make up this container are vibrating. Can I actually feel the vibration? No, because the vibration is not strong enough to be felt by the human hand. As far as the freezing point and boiling point of water, water will freeze on the Kelvin scale at 273 Kelvin and will boil at 373 Kelvin. Please remember to not use the word degree when describing temperatures in Kelvin, okay? We just state the number and we say Kelvin. We do not include degrees Kelvin, okay? There is no such thing, okay? Degree is only used for the Fahrenheit scale and the Celsius scale. And here you have a picture of Mr. Kelvin. You know, he looks like he was a very, very smart, intelligent man, okay? If you can tell that from a picture. So next thing we need is we're going to use this video not to watch it fully because I kind of want to get through it quickly. But if you want to watch it, you can come back into CK12, use your Google login when you click on the link that I have on the assignment, and it should take you straight to it and you can watch the whole video, but that's up to you. We're only going to watch just a little bit.
Hi everyone, and welcome to Biology Professor. Today we're going to learn how to convert between 3 different temperature scales. These are Fahrenheit.
All right, so we're going to stop there. This is right here, TF. If you are given Celsius, temperature in Celsius, you will use, and you're asked for temperature in Fahrenheit, this is the formula you're going to use. 1.8 times multiplied by the temperature in Celsius plus 32. For Kelvin, if I ask you to give me the temperature in Kelvin, but you're given the temperature in Celsius, all you have to do is add 273.15 and you have officially converted to Kelvin. Okay? Please write these down. Okay? And if you have to, pause it right now. We're going to jump ahead because she gives us another very important formula.
Divided by 1.8. If you'd like.
Now, this one is if you're given Fahrenheit and you're asked for Celsius, okay? Now, let's say I give you 125 degrees Fahrenheit and you need to solve it and you need to transfer it or change it to Celsius. Well, the first thing you're going to do is you're going to do 125 minus 32, then divided by 1.8. And for Kelvin, if you are given Kelvin and you're asked for degrees Celsius, all you have to do is subtract your temperature in Kelvin minus 273.15, and you have your temperature in Celsius. Okay, and I'm going to show you some examples real quick. Okay, so let me just exit out. Let's go to Jamboard. All right, so we're going to do two examples. One, the first example will change your Celsius to Fahrenheit. And then the second example will change Fahrenheit to Celsius. Okay, so we'll go forward and then we'll go back. All right. So if we have a question that says you have 27 degrees Celsius, I want you to change it and tell me the degrees in Fahrenheit. Okay. And at the same time, you have another question that says, okay, well, if you have 125 degrees Fahrenheit, change that to degrees Celsius. Okay. So we're going to use the formulas that were given in the video. And I cut out that video, but if you want to watch it, go ahead and watch it. Now, if we are solving for temperature in Fahrenheit, I need to take 1.8 and multiply it by our temperature in Celsius, okay? And then we're going to add 32 to that, okay? So let's plug it in. So if I'm looking for TF, I'm going to take 1.8 times 27 plus 270. I'm sorry, plus, not 273, my bad. Plus 32, okay? And that's supposed to be a 1. Oh my God, this one just got worse. 1.8, okay? I'll come back to that. Let's set up the next one. If my question is to solve for Celsius, I'm going to take my temperature in Fahrenheit. I'm going to subtract 32, then divide it by 1.8, okay? You will subtract, then you'll divide, okay? So the final setup will look like 125 minus 32, divide that by 1.8. Okay, so let me get my calculator so that we can practice together. And if you want to try this on your own, you would welcome that if you were to pause me. Okay, we've zeroed out. We're punching in 1.8 times our 27 equals, right? Or you can just put plus 32. 80.6. Okay. And we could do it all together. We can put 1.8 times 27 plus 32. And it's still the same thing. Okay. I did them all together. I didn't even put equals until the very end. All right. So that's 80.6. So I'm going to put 80.6 degrees Fahrenheit. And of course, you have to show all your work. You have to show the setup, the formula, exactly what you see here. All of this and this, including your unit, for full credit. Now, for our second example, converting 125 Fahrenheit to Celsius, degrees Celsius, sorry, we're going to take our calculator. We're going to take our calculator, and the first thing we're going to do is we're going to punch in 125, subtract 32 to get 93, and then we're going to divide it by the 1.8. And look at that. We get 1.66 or 1.67 if we round correctly. Oh. So temperature in Celsius, our final answer, 51.67 degrees Celsius. And of course, we box it up. Do we show everything that I have? Yes. Full credit, show everything that you have. Okay. If you need to see that again, you can pause and rewind. Now, the easier temperature scale is usually between Celsius and Kelvin, okay? So if you're given a temperature, for example, 35 degrees Celsius, and they want us to change that into Kelvin, Well, the only thing I need is my temperature in Kelvin equals temperature in Celsius plus 273.15. Okay? Now all I do is plug it in. TK is equal to 35 plus 273.15. TK, well, we bust out our calculator again. All right, we got our calculator out. There it is, zeroed out. 35 plus 273.15. Okay, look at that. 308.15. 308.15 Kelvin. Okay, easy as pie. Easy as pie. All right, so we have a secondary question. The secondary question says, I need to change 300 Kelvin to degrees Celsius. Okay? I need to change it to degrees Celsius. So what am I going to do? What am I going to do? What am I going to do? Well, I'm going to use the information that they gave me earlier. TC is equal to temperature in Kelvin minus 273.15. Sorry for making it small, but I'm running out of room. Okay, sorry. My bad. Okay, 273.15. I plug it in. 300 minus 273.15. And I punch it into my calculator. 300 minus 273.15. Oh, I messed up. Equals 26.85. 26.85 degrees Celsius. Easy, easy, easy. People love converting to Kelvin and back from Kelvin to Celsius because the formula is really, really easy and it's really hard to get lost. Okay, it's really hard to get lost because it's super, super easy. So let's look at the questions. Let's summarize our lecture. Temperature is a measure of the average kinetic energy of the particles in matter. The Fahrenheit scale defines the freezing point at 32 degrees Fahrenheit and boiling point at 212 degrees Fahrenheit. When it comes to the Celsius, water will freeze at 0 degrees Celsius and boil at 100 degrees Celsius. For Kelvin, the scale is based on molecular motion, with the temperature of 0 Kelvin also being known as absolute zero. This is the point where all molecular motion stops. Okay? All right, guys, you have your review questions to do for both sections. You have 3.7 and 3.11. Remember, do not do 3.16. It's not part of our lesson. We're not going to cover it. All right. You guys have a wonderful, wonderful day. Thank you for being so attentive. Bye.